We are in the habit always of looking for the differences in the y values, right? Always paying attention to our x's to make sure they are equal with intervals. So, in this case, they are, the x's are fine, and here are the y's. So what are the differences? Well, 8 minus 2 is 6. 20 minus 8 is 12. This one's going to be 24. And that one's going to be 48. Now, what's happening with those? Clearly, they are not the same. They're all being multiplied by 2. In other words, they are proportional, which is exactly what we should be expecting because didn't they tell me this is what I'm shooting for? Which is exponential. So, what does this tell me? This tells me that my b value is 2. I am multiplying each time by 2. So whatever my equation looks like, it's a times 2 to the x plus c. So now I have to find my a and c. So what do? We've done these before. These were in homework, they were in notes. What do? Plug in a point. And you have lots of points to choose from, but I think I would probably just go with the first couple. Doesn't matter, it'll work no matter what. But if I put in 1 for x and 2 for y, then 2 equals a times 2 plus c. If I put in 1 here and 2 here, so 2a plus c equals 2. All right, there's one equation. Then I'll plug in 8 for my y and 2 for my x, so that'll be 4a plus c. And then I have a handy dandy system of equations I can solve however I want. So maybe I'll just multiply through by a negative and make those c's disappear. So 6 equals 2a. So a equals 3. And if a equals 3, then it looks like c must be, is it negative 4? So what's my equation? Y equals 3 times 2 to the x minus 4. And if you have time, it's always a good idea, pick another one of your random points like 44. And if you put 4 in for your x, you should get 44, right? That's kind of just a little check you can do real quick to make sure that your model is correct. All right, what else? Yeah.
Negative 15.
The table represents an arithmetic sequence. Alright. So it's arithmetic. Oops. 1, 5, 7, 8, 15. And B, 19, 27, C, 59. Now, it is arithmetic. I'm supposed to be finding B plus C. All right, it's arithmetic, which means that I'm getting from term to term by adding something. Now, I'm looking right here. This is the 5th term, and this is the 7th term. And their total distance it traveled from the 5th to the 7th was 8. So since there's only one step in between there, each step must be 4. So I know in terms of my arithmetic sequence that my difference, my common difference is 4. Now, if my common difference is 4, and the 7th term is 27, then what does this, the 8th term have to be? 31, so C has to be 31. And working backwards, if I'm moving this way by adding 4, I'm gonna be this way by subtracting 4. Well, how many times would I have to subtract 4 to get from the 5th term back to the 1st term? 4 times. So 4 fours is 16, so this must be 3. So I want to know B plus C, so the answer is 34. Right? Easy. If you remember what it means to be arithmetic, that is not bad. Okay, what else? This can be over any of our review sheets. You have 3 of them. I feel like we haven't done much with our calculator. Let's look at number 20 on the review sheet. So I got a bunch of data, and it says the function gives the total number of iPhones sold worldwide yearly from 2007 to 2012. Okay. A quadratic regression is used to model the function. Okay? So, I'm going to go to my calculator, and I'm going to find that quadratic regression. So, let's go to stat calc, or excuse me, stat edit, and let's put in these numbers. Oh, I still have them in there. Alright, so put in those numbers. And then the problem tells me I'm doing a quadratic regression. So, so I'll go to stat calc and do quadratic. And I got 5.4536 x squared minus 3.8524x plus 4.82. That's what I got. Is that what yours looks like? Okay, so then it says, what is the residual for the number of iPhones sold in millions in the year 2009? That is when T is 2. Well, what was the, if we do this by hand, what was the actual value when T was 2? 20.73? So I could take 20.73 and subtract what I get when I put 2 in here, and that would give me the residual for T equals 2. Okay? So that seems okay, that seems manageable. Find the year in which the number of iPhones is 200 million. Remember, all these Y's are in millions. So when you answered your residual, whatever the difference was, it was millions of phones. Okay? So if it was 1, it was 1 million phones, either more or less than the actual. Okay, find the year in which the number of iPhones is 200 million. All right, what are you going to do here? I would graph this equation. Now, it's already stored in my calculator, so I don't even have to put it back in. It's already there. And right along with that, I want to graph 200. What's it, 200 million? Okay. And I'm going to look for where they intersect. Now, I'm going to have to do a little window work probably. Do I want X to be negative? No. I want y to be negative? No. And y has to be at least 200, so make it 250 or something. And hit graph and see what happens. Whoop, I gotta make my x's bigger. Okay, so second cell, intersect. Looks like it happens about 6.346, what is 19 years? So what does that mean in terms of the problem? Remember, these are years after 2007. So sometime in the first half of 2013 is when we have 200 million phones. All right. Now, the data is already in your calculator, but now it says, what is the exponential model? Okay, we can use exactly the same data, but now when you go to stat calc, you're going to choose exponential. And come up with a different looking equation because it's exponential. Okay, and then it says find that if we put in 6, so we'll just press Y, parentheses 6, and then we don't have to worry about round off, and it looks like 389.7957 million phones. Now, with the quadratic model, when we had about 6, when x was about 6, how many phones did we have? 200 million? So now when we put in 6, now we have almost double that. So one of these models hopefully is better than the other one. So we're going to graph the residual plot for each one. And I'm not sure, I did these separately. I don't think you can do them at the same time. So I did the residual plot for each one. So the exponential is in my calculator right now, so that's going to be the easiest to get. Don't forget to zoom stat so you get a better picture. And for my exponential, and remember, if you hit trace, it will actually tell you where the points are. So it's negative 1.4. And the next one is 5.11. And the next one is 5.95. So that will help you scale your paper. This is 6.5. Negative 3.6. And whoops. Negative 46. So I got a plot that look like that. And for my scale, I used 12s. And of course, that one was way down there. And of course, this was 1, 2, 3, 4, 5. So that was the residual for the exponential. Now, unfortunately, to get the residual for the other one, you're going to have to go back and redo stat calc quadratic. So that's what we'll have to do. We got the data in, so that's not a problem. We just need to get our quadratic regression back again. And then you can do your regression for that one. You can remember also, if you have your columns set up, you can get your residuals out of there. So this is what, where's my first one? So this is what I got. So the first one was -3, the next one was 5. Alright, so that was the plot I got for my quadratic. Alright, so I got that thing up there and this thing right here, and now choose the best model and explain your choice. Yes, Julia?
I just have a question. How do you get to graph the residual of the exponential and not the quadratic?
You have to go back in. So it's going to graph whatever you last built the model of, because you saved that as y. So if you did stat calc, did the exponential, then it's going to graph the exponential. As long as you saved it, where it says save as y or whatever it says on your calculator, it will save it, and then it will do the exponential. So, who feels like one of these is better than the other? Frankly, I don't like either one of them. That's what I wrote down. I said neither one seems particularly good, because what makes a model good? The residual shows no pattern. This kind of has a pattern, but it's a whole lot better than this one. What in the heck is happening here? I think that is going to keep getting more and more wrong. Remember when we did the data for 6, we plugged in 6, we got that number that was double what the other model showed? I think that's just going to continue to get worse and worse, because what do exponentials do? They just keep growing, and the more it grows, the more different it's going to be than the actual data point. So I said if I'm forced to pick, I'm going quadratic. I'm going quadratic because at least I'm not as far off the model on all of my options. Does that make sense to you? You see what I'm saying? Yeah. All right, what else? Let's be sure we're clear on money problems. We did some of those in our other reviews. Let's suppose you invest $500 at 3.4% compounded quarterly, and your friend invests $500 at 3.4% compounded continuously. Who's gonna make more money? This is you, this is your friend. Your friend's gonna make more money. How much more money is your friend gonna make? Well, I don't know. I'm gonna figure out how much money I'm gonna make. I'm gonna figure out how much money he's gonna make, and then I will subtract them. So, how do I figure out how much I'm gonna make compounded quarterly? 500. 1 plus 0.034 divided by what? 4. This is in a year, so it's just gonna be 4 times 1. And then how much is my friend gonna make? 500 e to the 0.034 times 1. So I'm just gonna figure out what those are and subtract them. I can do it all at once. I don't need to type them in individually. I can subtract. Oh gosh, in a year, not as much as I thought. Anybody have a difference? Get a difference? Yeah, it's about 7.4 cents. So about 8 cents, you can go with 8 cents or 7 cents to the nearest cent. So the difference in those is about 7 cents. Now, what would happen if we did this over a 50-year span? Then the difference would become a lot bigger, right? Okay, that's money, okay. We've done problems where we knew that the half-life of something was, let's say, 60 years. Okay, so when we built our equation, let's say we started with 100 grams of it. When we built our equation, we did this. But what did the T represent when we did that? The number of half-lives, right? So after 60 years, you put 1 in there. In 120 years, you put 2 in there because that's how it's halving. But then we wanted to know, okay, well, what is that on a pure year, on a per year basis? So then we would have to divide it by 60. So we could do 1 year. And that means that can be split and say, okay, 1/2 to the 1/60th to the teeth. And then this will tell you, whatever that decimal is, that will tell you the growth, or decay in this case, for a 1-year period. Because the half is for a 60-year period. So that would be a 1-year period. Right?
So the second equation says what?
This right here is going to tell me how much per year I'm losing. That number is 98.85. So that means every year I'm losing what, 1.15% of the stuff. After 60 years, I would lose half of it.
So the second equation, if we wanted to find like 3 years, we can just put 3 instead of 9.
Put 3 right here. Yep, put 3 right there. This is the same equation, so yeah, you could do that too, it doesn't matter. It's the same equation. You just have to pay attention because we've had several problems where we've known what's happening to a quantity, but it's over a certain number of years, like it triples every 3 years. Okay, so then we have to figure out, okay, so what does that mean per year? So that's kind of what we get right there. Alright. Trying to think. Okay, well, I would definitely look at all my review materials, and I would definitely practice, because it always looks easier